Hey guys, welcome back to the channel. So 2 pointers, right? So we are currently doing sliding window in the 2 pointers, and there are two more problems left. And it's easy one. We should have kept the easy ones before and the tougher ones later. But anyway, let's do this. We are given a binary string s. Return the number of non-empty substrings that have the sorry. Uh, did we solve this already? Don't know whether or not we have solved this or not. Since we didn't, well, we were given a binary string as return the number of non-empty substrings that have the same number of zeros and ones. So we were given a substring as and return the number of non-empty substrings that have the same number of zeros and ones. Okay, and all the zeros and all the ones in the substrings are grouped consecutively. Okay, right. So it should look like this: 00 0011 01 011 01 1100 10 and 0011 and 01 in this case. So let's go here: 10 01 10 and 01 4. So it's all equal to 0. Let's keep all equal to 0 for or in range of length of s 0 count equals to 1 count. Let's keep it simple. Count 0 1 if so. And let's discuss the approach first. Okay, so what we can do, we can go through the zeros and count the number of zeros. We have to consider only consecutive zeros. So I guess we have to check the previous ones also. It's kind of checking, I mean, fetching a palindrome. So how do we fetch it? 0011. Let's do one thing. So we'll consider let's make it a dictionary 0. Let's move it from 1. Count of if SF are changed, if both are not true, if we check it properly, we'll get the number of distinct values from the both. So we are checking if the previous element and the current element are same or not. If both are same, we are continuing it. If it is not, we are checking if the other, I mean, the new element what we got here is 0, then we are counting them. And again, if we encounter 0, I mean the different oriented number, then it will go to elif again, and this time it won't give 0 because it's already filled. Then it will come to the else. We are taking the minimum of 0 and 1 and moving L2 or uh, so in three of them we are doing count of s of r plus equal to 1. I don't know. So let's do one thing. Hmm, plus 0. Let's see if it works. Hmm, let's check count. So initially, right. So if both are same, then we are missing something here. One. 1, 2, 3. so far. Something's wrong though. Let's see the order how count's going. Usually both are 0 and we get 0. We should get here 2, but let's see. So 2 zeros, 2 ones, fine. Now 0 became 1 again. Right. Now we have 2 ones and 0. And if 0 become 2 and 4. This is the first step. 0 to 4. 0 became 1 again. 0 became 2. Now it should give us count of 1 should change to 0, but it didn't. How did 1 became 3? If not S of R. So here itself this should give a false value. If it is false, So initially 1 0 and okay, 0 0. Now 1, so far change it to 1 and 0. So this should give us the okay 1 1. So 1 incremented to 2. Now 0 1 again. Now we got 0 0. We have to, like it's changed it to 0 1, right? So 0 became 1 again. 0 0. 0 became 2. 2 zeros to 1s. 1 0. So this should return false and it should trigger the if condition. And right, we should update L2. Fix the file. So sorry. This 0. So 0 1 2 3 0 1 2 3 4. Now will become 4. L2. Now L should become 1 1. So 4, right? Yes, this will do the thing. Let's see. 0 4. Equals to or minus. So 0, I mean 1 0, 2 0, 2 1, 2 2. So it is triggered. Now L is 0 and R is 4. So shuffle is 0, R is 4. So 4 and 0 both are same. Now L should upgrade to 4. Zero, 1. Let's see the interest question and how close it is. It is 2 and it is 4. Okay, I got it, guys. So SFL, okay. Let's see now. Now L is 2 and R is 6. So 2, 3, 4, 5, 6. Here 0 is 2. Here is 1. It should be kept at last, I guess. So if R is now, I think it will go fine. Right. The length will be 15 and 10 to the power of 5. Fine, let's see. No. Let's see if all of these are going fine or not. They are going fine. So let's try submitting it and let's discuss the inclusion later. There will be one test case. 1001. I think we have to print the so 0 1 so 1 2 3 so this 1 0 1 it's at 2 but it is at 3 0 1 slow at 1. Yeah. So let's try this again. 01, 02, 13, 14, 25, 26, 33, 36, 4, 5, 6, 7 to change, 6, 7, 8, again at 9 to change. Let's try submitting it. If it goes fine, then let's discuss the intuition. Right, it went great, but seems like it can be done uh, easier way. But it should be order of n, right? It should go at least order of n. No problem. Let's dig how we did this. So what we're doing is initially we are initializing a pointer L and a dictionary to count number of zeros and number of ones, only consecutive ones. And so initially we are starting the uh, it might be 0 or 1. So we are incrementing the first one because here we didn't count 0 value, I mean 0th index. So we are incrementing the 0th index here. You can directly keep 0 here, no problem, instead of L. And we're going from 1 and checking if previous value and current value are same or not. If it is same, then we will increment the count. If it is not same, then we are checking if the next one is 0 or not, because initially we'll have one value filled and other will be 0. So if it is 0, we are continuing to increment it. If both of them are false, that means it's not the initial case, and we have encountered a different number like 0 0, right? Here 1 1 0. So we encountered a different number. So what we should do is we should uh, change the L pointer to this one's position. So what we are doing is we are incrementing L to the number of uh, previous number positions, like here it is 0. So we are incrementing 2 plus 2, which will keep us here, and we are changing it to 0, changing the value to 0. Why we are doing like this is, so we are checking, like we are storing that count in a temporary variable, and we are changing the count of 0 to 0. I think we don't need to do this. Nah, it should be like this only, because so L and temp are interrelated. If L upgraded, then temp, I mean if L changes, then S of L also changes, which will make the unintended value to 0. So we make it 0 and the count will continue. So in this case, we got another 0, right? After getting the 0, we have entered the loop. So we made it 0 and we incremented it, which will give two ones and 1 0. And we are not checking the final count, like final answer here. So we are doing it outside the loop and returning the answer. And let's see if there are better solutions exists. Oh, so it's looking elegant and better, I guess. Let's see. If S of I starting from 1 2, previous is 0. I mean, it is L, I guess in this case. Current is 1. So if S of I equal to S of I minus 1, if the previous and the current one are same, we are incrementing the current value, else if both are not same, then result is minimum of, okay, he is doing the same thing. Okay, so incrementing previous, I mean changing the previous to current position and upgrading current to 1. It's almost the same, but instead of using a dictionary, he's doing it in a cleaner way. Let's change it to that. It seems very elegant. So let's change this to that. Uh, so count will count. So this count will count all the previous. I mean all the zero, either all the zeros or all the ones which are on the left. And if the value changes, then we are adding the minimum of Lcom account. Initially L will be 0, so initial for the starting it won't change, and so we'll have count equal to 2, and the value changes right here. So now the count of ones will be 1 because the value changed here, right? So we updated count equal to 1, and L2 this position. Now the count will be 0, and count will be 2, and L will be 0 because initially L will be 0, and we take minimum of L and count, which will be 0 initially, and later if we increment this like this, the count will be 2 again, and it will go to this 0, and it will come to this else condition, and we'll update L to count, which is 0, 1, 6, 4, 4 in this case, and count to 1 again. Right. So we should take answer before the count, I guess. So before we should take the answer before updating the count. Let's try running the code and check if it is correct. Right. Sorry, we should take the answer before updating L and count. Right. So it will exclude the last one. So let's submit it. Hopefully you guys understand the intuition. So the main motto of this training session for me is especially is to intuitively explain the uh, problem and the solution. So if you guys didn't understand, let me know in the comments. uh, I'll make it more intuitive and upload a video again. Fine guys, I hope you guys enjoyed the video and you learned something better. Thank you guys and goodbye.